why are sweeteners sweet if they are not sugar? What actually makes them taste sweet? Sweetness is not really a property of the product itself. Sweetness is a reaction of our taste receptors to certain molecules. When these molecules interact with the receptors on the tongue, the receptors send signals to the brain, and the brain interprets these signals as a sweet taste. But why does this happen? If we simplify it a lot, this likely developed through the evolution, because our body becomes familiar with glucose from the very first days of life, starting with mother's milk. Lactose in milk consists of glucose and galactose. Glucose is easily absorbed and serves as a fast source of energy for both the body and the brain. Because of this, our brain developed a positive response to this taste. Like, this is something pleasant, this is safe, and this is a quick energy. But then another question appears. If sweeteners are not sugar, why do they taste sweet too? To answer this question, let's first look at why regular sugar tastes sweet. Table sugar is sucrose. Sucrose consists of two molecules, glucose and fructose, connected together in a specific way. But our taste receptors do not react simply to sugar. They react to the shape of the molecule and the arrangement of atoms. If we simplify it, the molecule must fit the receptor like a key fits a lock. And this is exactly why not only sugars can taste sweet. So what about sweeteners? There are many different sweeteners, and they are all very different from each other. But let's explain this using one simple example. Let's compare glucose and allulose. Their chemical formula is almost identical. This means they contain the same number of carbon, hydrogen, and oxygen atoms. But the difference lies in the special arrangement of atoms inside the molecule. Allulose is what is called an epimer of fructose. Its molecule is almost identical to fructose, except for the position of one hydroxyl group. And this small shift changes a lot. For sweet taste receptors, the molecule still remains similar enough to sugar, so the brain perceives it as sweet. But for enzymes and metabolism, it behaves differently. Sometimes even a very small change in molecular structure is enough for a substance to remain sweet to our receptors while behaving differently inside the body. But there is also another type of sweetener. For example, Rebaudioside A, one of the main sweet compounds found in stevia. Its molecule doesn't resemble regular sugar at all. It has another chemical formula. It is a large and complex molecule consisting of steviol backbone with attached glucose fragments. These glucose fragments, together with overall shape of the molecule, allow it to interact with sweet taste receptors. So receptors do not respond to sugar itself. They respond to a specific molecular shape and configuration. And this is why substances with completely different chemical structures can still be perceived by the brain as sweet. At the same time, different sweeteners can activate receptors differently. Some produce a taste very similar to sugar, others may additionally create bitterness, herbal notes, or cooling sensation. And this is exactly why developing a truly good sugar-free flavor profile is much more complicated than simply adding any sweetener, because in food science, sweeteners is not only about taste. It is also about chemistry, molecular structure, receptor interaction, and ingredient behavior inside a product. Want to learn more about sweeteners, food science, ingredient functionality, and sugar-free formulation? Subscribe to my YouTube channel.